polygon we made earlier. That's what it's going to look like at the end. So we start off with a 3D page. I think the blue background makes it easier to see. Axes at the top here, left, edit axes, and if we go into options we can make the numbering scale actually sit on the axes rather than on the outside, and we can remove the bounding box, which is useful in other situations but in this situation maybe less so. And there we've got the new axes, and then we just enter in an equation. Let's do that again. Y equals x squared, and it appears in 3D, and we're just going to double click on that because we want it to be plotted as a 2D so that we can find the area under it, because we won't get the area option unless it's plotted as a 2D equation. So I double clicked on the equation I'd entered and just selected plot as 2D. I could have done that at the start, but it's just to show you. Okay, and now it's not selected because it's red. I'm just turning that round. I can also turn it round using the grab hand, which means I definitely can't select anything. That's the advantage of the grab hand, it's not for selecting. Then I left click on the curve, right click, and I can find an area, and I'm going to do that between the points -2 and 2, and I'm going to make it 10 divisions. So I'm going to divide that area between -2 and 2 into 10 divisions, and I'm going to choose rectangles that underestimate the area rather than the trapezium-Simpsons or rectangle rule for finding areas under curves. And there we have it. And then if I right click on that and left click, I get the option to find its volume. So I'm going to find its volume, and I want it to rotate around that. But before and you can see I've got the turtle that I'd already selected before starting all that, so that it will do it slowly and gradually. And so now when I press OK, that volume is going to slowly appear, as we can see, and I can turn that so students can see what's happening. Fantastic. And the next thing is you'll see I've got these ones open, because that's from the previous page. So if I double click on here, or just single click, sorry, and then the animation button at the top, I get volumes, which means that I can undo my shape, and you can slowly see it, and the whole class can slowly see it undoing. And then I can click on there just once in that pink bit where it opens up, not on the curve, that bit there. And again, if I click on the animate object lightning strike there at the top middle, I can change the number of divisions so that the students can really see that as I increase the number of divisions, the infinitesimally small cylinders are a very, very closer and closer approximation of the actual area under the curve. That's a really nice visual representation of how integration captures the area under a curve.